Hi geometry students. Today we're going to be, I'm just going to go over the last lessons that I was not able to do in class. So starting with lesson 3 on angles, I wanted to start off just with some notes, and you don't have to, you can write the notes on your own, but just you could follow along and just make sure that you actually understand the concepts with me. If you have any questions, go ahead and post them on the comment line. So first we're going to start off with ray. So most of you know that a part of a line that starts at an endpoint and extends indefinitely in one direction. So I'm just drawing a ray so you see. Okay. So that would be a ray. So this would be point maybe A and point B. So we know that probably from algebra that this is called a ray. It's named by the endpoint and any other point on the ray. Okay? An angle, you know as, let's just write a couple things down, is a figure formed by two rays with a common endpoint. So I'm just going to draw an angle so that we could see some examples. So these are two rays, and you see them by there's an endpoint here, and then two lines that go indefinitely. That's an angle. The vertex is the common endpoint in the angle. So here, this right here would be the vertex. Okay? And then the sides are the rays of the angles. So these right here are sides. Okay, so as long as we have that, we can move on. Okay, so angles can be named in several different ways. Okay, so let's draw another angle up here so that you could see different ways to name an angle. And I think most of you should know this already, but just in case, we'll review. So let's just call this vertex B, and then ray A and ray B. All right, so this angle can be named three different ways. It can be angle B. Okay, this is the symbol for angle. It could also be named angle ABC, which is the 3 points right there. And it could also be named, oh, why is this two B's? This should be a C. Never mind. Sorry about that. ABC. It could also be named CBA. Angle CBA. And last but not least, if you haven't already guessed it, it could also be called angle 1. Okay? So those are the different names for the angles. Now let's go ahead and look at example number 1 on page 14. Okay, so example number 1, and I'll draw it here for you the best I can. Okay, so we have here ray P, ray Q, ray R, and vertex S, angle 1 and angle 2. All right, so the question is, name 3 rays in the diagram. So 3 rays would be SP is one of them. So we'll write SP and the symbol for ray. Another one would be SQ. And the third one would be SR. So we see that it's from the vertex to the end there. Okay, so those are the 3. Question B asks, name 3 angles in the diagram. Okay, so 3 angles, there's multiple angles here, so we can actually choose a few. One of them could be this one right here. So you could say angle, we'll start with the numbers. Angle 1 could be 1. Angle 2 could be 1. You could do this angle here, which would be called PSR. It can also be called RSP. P. As long as there's 3 points, you can use the 3 points. You can also do the smaller angles, PSQ, angle PSQ. You could also do QSR, angle QSR. I think that's enough. It only asks for 3 examples, or 3 angles in the diagram. I think we did 6. So I think that's good enough. Let's see. And the last question for example 1 is, could PSQ also be referred to as angle S? Could PSQ also be referred to as angle S? What do you think? The answer would be no, it cannot, because there's 3 different angles with S as a vertex. It's this angle PSQ, QSR, and PSR. Because there's 3, it cannot be named angle S, because there's other ones that it'll be too confusing. We won't know which one you're talking about. Okay, so let's move on. Okay. All right, so next definition is a protractor. Is it a protractor? I've actually been using my protractor. It is actually this little thing right here, and it's used for to measure angles. We see here that angles on the inside over here are the degrees. It goes from 0 to 90, all the way back to 180 over here. And on the outer end, you also see 0 to 90 and all the way back to 180 on the top side, so that you can measure the angles depending on which way they're open to. Now, degrees is another definition you need. It's just a unit of angle measurement that's equal to 1/360th of a circle. Okay, so we know that a circle is 360 degrees. A degree is just 1 out of 360. So let's review postulate 3. Postulate 3 says, what's the protractor postulate? Protractor postulate. And it says, given a point X on line PR, consider rays XP and XR, as well as all other rays that can be drawn with X as an endpoint on one side of PR. These rays can be paired with the real numbers from 0 to 180 degrees, such that, okay, so this is getting a little bit more complicated. So let me just read it to you really fast, and then we'll draw it out for you, okay? So again, given a point X on PR, okay, so let's just draw PR. Okay, given a point X on line PR, so PR, and this will be X. Okay, so given a line X on PR, consider rays XP, so this is XP, and XR, as well as all other rays that can be drawn with X as an endpoint on one side of PR. These rays can be paired with the real numbers from 0 to 180, such that XP is paired with 0 and XR is paired with 180. If XA is paired with a number C, okay, so let's draw XA. This might be confusing, but I'm sure it'll make sense to you in just a second. So let's call this A. So if XA is paired with a number C, so whatever this number is, whatever degree it is, in other words, when you measure it, it's the degree that it is, they're calling it C. So C degree. And XB is paired with a number D. Okay, so let's do X, maybe this way. We'll do XD. So we're going to call this endpoint over here D. And this D is, I'm sorry, is that what we're calling the XA and XB? Okay, so B. Okay, and this is D degrees. D representing, C and D representing a number of degrees. Then what we're going to do is, if it's paired with a number D, then the measurement, remember M means measurement of angle AXB is equal to C minus D. And what is this called again? Absolute value, right? Okay, so the measurement of AXB would be the difference between the degrees C and the degrees D. Okay, so let's look at that. I hope in, is there a, oh, I see, okay. So let's just say, for instance, it was this for, well, let's just measure it, actually. Let's say this was, okay, this is 150 degrees. So C equals 150 degrees and D equals, well, not 150, it's smaller than 90 degrees. So this is, sorry, 50 degrees, okay? And D equals, so it's 50, looks like it's 31 degrees. So using this formula, what is the measurement of AXB? Well, the measurement of, of angle AXB is equal to the absolute value of 50 minus 31, which equals, okay, so 50 minus 31 is negative 19, and the absolute value of negative 19 is 19. So, thank you, Bella, for that. That echo.
Welcome.
All right. Are you paying attention? Because you should be getting this too.
I was getting water downstairs.
Okay. All right. So let's move on. We have angles. Okay. So this should be a review. Acute angle is not a cute little angle, although it is very cute. It actually means that it's less than, it's 0 degrees to 90 degrees. Sorry, between 0, it's not 90, it's 0 to less than 90 degrees, okay? So an acute angle would be maybe something like that. And then an obtuse angle would be, it's 90 degrees to less than 180 degrees. Okay, and this might be, does that look like an obtuse angle? I have a protractor here. Why don't I use it? Let's see. Okay.
Oh, the camera's running low on battery.
Alright, and then a right angle, you guys already know what a right angle is, and that's exactly 90 degrees. So let's just draw a right angle. And then we'll do a little square for the right angle. And then a straight angle is actually just a straight line. It's 180 degrees, exactly. All right, so those are the different angles. All right, so now we're going to go into examples. Example 2. Example 2 says use a protractor, and good thing we have one here, to measure angle ABC and classify the angle. Okay, well, the answer is already there, but I do want you guys to go through the practice of actually measuring it. And the way we measure is you want to make sure you put the vertex is right where the dot is, and that this line here at the bottom is one of the bottom line of the angle should be right on it, so that we can see exactly. And see how the angle just like stops right there?
Nope, just accidentally took a picture.
All right. Can I get a pencil? Where's the pencils?
They're right there in that little.
Okay. So
the battery's
what
like
I would do
almost dead.
Okay. Sorry. What I would do is I would actually extend this angle out so that I could measure it more precisely with a pencil. Don't use a pen. Huh?
Okay, I'll just say it on the tape. Can you bring the protractor more over here? Because it's only focusing on your hand.
Oh, sorry. Thank you for helping me.
Sure.
Okay, so still going. It's about 130 degrees actually if you follow it all the way through, because it's going off the page. So let's look at our answer, and it's 130 degrees. Yay! Okay, so because it's more than 90 degrees, it's an obtuse angle as well. All right, so if you look at the protractor, use the protractor to define to measure DEF, and I'm gonna do the same thing with DEF, and I'm just going to extend out this angle here so I could read it. Okay, and it's putting it right there where the E is, putting this line right next to it, and out. It's 140 degrees, or I mean 40 degrees actually, because it's less than a right angle. So I'm looking at the bottom, at the top one over here. So it's 40 degrees. And yes, sure enough, it's 40 degrees, and it's such a cute angle. It's an acute angle. And then over here, GHI, and see how you could just choose whichever line you want, either this one or this one, but it has to line up to the bottom over here. So we're putting the, let me make it longer here again.
Pretty soon I have to play commercial or something and charge it for a little bit.
Okay. Okay, and this is a straight 90 degrees right here. You see that? It ends right there. So it's a 90-degree angle, and it is a right angle.
What a classic.
Okay. Do we have time for another postulate?
No? No. Sorry. Oh, wait.
Oh, wait. We just have one more. Come on.
Mom, it's like literally about to die.
Postulate 4.
Brief commercial.
No. Postulate 4 says the angle addition postulate. If point D is on the interior of ABC, then, okay, so let's just draw that out really fast before the time runs out on my clock here. Okay, so we're gonna do an obtuse angle.
The camera's so shaky. Please forgive me. I'm just trying to focus.
Okay, thank you, Bella, for the commentary. You can
I can shut
pretend
up
like
now?
you're quiet now, like you're not even here. Okay, so this is B.
I'll shut up.
And I hope you're taking notes because... Alright, so if point D
4
is in the interior of ABC, then...
2, 1. Sorry, bye.
Really?
Yep.
Okay. Alright, so we left off at postulate 4, and we now have battery on the camera, so we can keep going. And that's the postulate 4 is the angle addition postulate. So let me just title this. Okay, and as we were saying, if point D is in the interior of angle ABC, then the measure of ABD plus D angle DBC is equal to the measure of angle ABC. So basically what we're doing, this postulate just says if there's an angle inside of a bigger angle, the two angles added together will equal the size of the whole thing. Okay, that's all the postulate is saying. I hope that makes sense. So we're going to move on to example 3 using this postulate. Okay, so let's look at example 3. It says, okay, oops, where is my protractor? Here it is. Okay, so it says that, okay, here's angle RSU. So we're going to just label this.
I'm going to take my notes.
RSU. Okay. So the measure of, and there's an angle within the angle, like I said. And this is T. Let's just put a little arrow so we can see the rays. The measure of RST equals 22 degrees. Okay, the measure of angle TSU is equal to 60 9 degrees. Find the measure of RSU. Okay, so we, this is not that difficult actually, but let's go ahead and go through the exercise so we understand how to do this postulate. So measure RS, measure RST plus, that's not going to give me enough room. Let's do it under here. Measure RST plus measure TSU is equal to measure RSU. Okay, and just plug in the numbers now. So it's 22 degrees plus 69 degrees equals 91 degrees. So RSU equals 91 degrees. Okay, and what kind of angle is it? It looks like a right angle, but because it's more than 90 degrees and less than 180, it is an obtuse angle. Okay, hope that makes sense. All right, I thought we were done with definitions, but I guess not. We have a couple more. Bisect. Okay, so that's the next definition. Bisect. It just simply means to divide into two congruent parts. To divide into two congruent parts. And remember, congruent means equal. An angle bisector is a ray that divides an angle into two congruent angles. An angle bisector is an array that divides an angle into two congruent angles. And congruent angles, I know you know what this means. We keep talking about congruent angles. Simply means that they have the same measurement. Okay, so they equal same, two angles with same measurement, with equal measurement. Okay, and then the last one we're going to define is arc marks. Okay, and that's just what it sounds like. It is basically just marks that that are on angles. For instance, let me give you a okay, so this angle, that's an arc mark. This is an arc mark. This is an arc mark. Okay, so now with that in mind, let's go ahead and do example 4. So let's take a look at that. Using angle bisectors and congruence marks. Okay, so the measure of, let me give myself some room here. The measure of ABC, okay, so let me draw this very complicated looking set of angles. And you could probably follow along in your book. It is example 4 on page 16. All right, so we're going to call this right here A. The vertex is B. This is C. This is D, E, and F. And there are 2 arc marks here. Okay, so it says that the measure of ABC is 44 degrees. Okay, so I'm just going to write myself a little note right here. This is 44 degrees. BC, the ray BC bisects ABD. If it bisects, then we know that it is actually dividing it into 2 equal congruent parts. That means that this is also 44 degrees. Okay, so make sure you're reading the examples carefully so you can actually start defining things before it asks you the question. The measure of EBD right here is 23 degrees. And we see that the arc mark tells us that it is the same size, right? The arc marks tell us that it's the same measurement. So what, let's see, find the measure of CBE. Actually, it won't even tell us what EBF, it doesn't matter. So C, we're looking at, let me do this with a different color pen so that you can see. It is asking us, what is CBE? So what is this right here? Well, we actually kind of already defined, because we did some work initially, we can see what the answer is. So because, like I said, BC bisects ABD, we know that this is 44 degrees. So, so let me see, angle ABC is congruent to angle CBD. Okay, so that means that and angle ABC is, yeah, CBD. So since ABC is 44 degrees, we know that CBD is also 44 degrees. And we know what this other one, because it was already given to us, DBE was already given to us, so it's simply 44 degrees plus 23 degrees equals 67 degrees. So the measure, and this is how you would write it out, the answer. The measure, M is for measure, of angle CBE is equal to 67 degrees. All right, pretty simple. Okay, last one. Uh-oh, red's not very friendly here. Okay, so this is an application example, and I'll read you the question. It says, Louis runs a restaurant. He knows that he has about 900 customers, so I'm just going to write that right here, just so I know what the facts are. 900 customers a day. The circle graph in the diagram shows what percentage of his customers fall into the given age brackets. He wants to know exactly how many of his customers between the ages of 15 and 20 are between ages of 15 and 20. Use a protractor to measure the angle and find the number of customers that fall into the 15 and 20 bracket. So what we're going to do is we're going to extend out here's the age brackets of all the customers. We're looking at this blue section, which is the 15 and 20. So let's go ahead and measure this, because we know that this is a measurement of we know it's going to be 360 degrees is a full circle, so this is going to be a portion of the 360 degrees. So let's go ahead and measure. This will be the bottom line over here. So let's go ahead and measure. I think I need to put out further. My protractor's not that. There we go. That should do it. All right, so we're gonna line up this line right here with the bottom line right here. Okay, and the vertex is right where that circle is. Okay. And it says that because it is over 90 degrees, it's at 120. So it's 120 degrees. Okay. 100 on the angle measures 120 degrees. 120 degrees. Out of a full circle, which is 360 degrees. Okay, so we know that that if you actually factor it down, this would actually factor down to, well, let's just do it quickly. We'll take out the zeros. 12 over 136 is actually 1/3. So basically what this means is that the customers that are age 15 to 20 years old are 1/3 of all of his customers. How many customers? Okay, so 1/3 of 900 customers is basically 1/3 times 900 will give you 300 over 3, or Yes, 300 customers would be the answer.
Oh,
Okay.
Bella was right.
All right, that's it, guys. We'll continue with lesson 4 tomorrow.
Yeah.